The next one, this is when you multiply the outputs. And so here you're doubling all the outputs. This one is interesting because if you double 1 over x, you can actually multiply the 2 on top. So you'll see it on top as well. The half, this one's interesting because if you multiply by half, you actually see 2 on the bottom. But we might want to just write it like that. And then a half, -3. So you can see it like that. And so what happens here in Desmos is now we're actually like, so if I just take y equals x squared, now we're actually multiplying the function by a number on the front. And so notice that like if we change this to a and add the slider, if a was 1, it looks like this. It's just the regular function. But if a was like 2, 3, it's actually stretching vertically up. And then if a was a fraction, like 0.3 or 0.5, it's actually compressing vertically down. And if you look at it, it's actually just like vertically stretching. It's timesing all the y values by that number. But we call it vertical stretch. And then if it's negative, it just opens down. And so this is very similar to like a quadratic you saw last unit, but like or last year in grade 10. But if you had, instead of this, you had 1 over x, you could see that like it's vertically stretching it out. So it's multiplying the y values higher, and then it's compressing the y values down in as you get closer to 0. And then when you're negative, you're like actually reflecting vertically. And so the negative actually vertically reflects. Okay. And so that's the notes we would take. Like we would just say vertically stretches or compresses. If it's greater than 1, it's a stretch. If it's less than 1, it's compression. Notice that I use for the absolute value function. If the total number is greater than 1, if the total number is less than 1, then it's between 0 and 1, and it's compression. And if it's less than 0, it's a reflection. And it's a vertical reflection or in the x-axis. The next one is shows up when you're doubling all the inputs or halving all the inputs or multiplying all the inputs by -1/3. So what that looks like in Desmos is down with the x. And so say we add a 2 here, or we'll call it an a, and then we can kind of shift this around. Let's look at a different function just to help you see this one. Let's look at the absolute value function. If you had this kind of thing here, and so this is a is 1, it's the regular absolute value function. But as you get bigger, what's happening is it's actually horizontally compressing the numbers. You want like smaller numbers to start with, to plug in. So what it's doing is it's pushing those numbers in because all the numbers are being multiplied, say, by 2. So this would be like y equals 2x. It's the same thing. Because all the values are going to be doubled, you actually want double the size anyway. So instead of going to 2 and getting 2, you can see that like if you looked at a table of values, 2 doesn't give you 2 anymore. It's 1 that gives you 2, and it's 2 gives you 4. And so like a number like a half might be nicer to sub in, 1 over 2. And 1 would be nicer, and then that would give you the 0, 1, and 2. And then -1/2 will be like a key point, and -1 would be a key point. And so what happens is like to get those same y values, the 2, 1, 0, 1, 2 as the base function, we're really halving all of the x values because all the x values are going to be doubled. And so if we take -1, -1 becomes -2, and then the output's 2. -1/2 is actually a nice number to sub in because it's going to be doubled and get you -1, and then that gets you +1. And if you look at that, I don't think I can convert that back, but if you look at y equals the absolute value, or let's look at square root of 2x versus the square root of x. Let's do a again. And so if a was 1, you can see it here too, like as you get bigger, it actually gets pushed in. It looks like it's growing vertically, and in fact it's similar to that, but like really it's just the x values are getting pushed in from this side. And so it's actually compressing it. And if you got closer to 0, it's actually stretching it. This one's a bit opposite of what you'd expect, or what the verticals do, because a half right now it's horizontally stretching it out. It's doubling all the x values versus halving them. And a 2, it's horizontally compressing it. And so it's actually the opposite of what you would think. And the reason why is because those outputs are being multiplied by a factor before they're going into the function. And so what we say is like, if you had something like up here where you got 2x, this is actually a horizontal compression. And what you do is you multiply all the x's by a half. This is a horizontal stretch. And what you do is multiply all the x's by 2. This is a horizontal stretch and a horizontal reflection. And so what happens when the outputs when you have a negative number, you can see like it's just horizontally reflecting it. Everything's happening horizontally here because it's happening to the x value. It's multiplying by the x values, not the answer after you get the output. Okay. So that's just a quick overview of what each one of them do. K is inside. It's really if you have greater than 1, since we're multiplying or dividing the inputs, we need less than 1 is a stretch. Greater than 1 is a compression. It's similar to the shift in that it's sort of the opposite of what you'd expect, but it's also because you're changing those inputs. You want, like if you're doubling the inputs, you want smaller ones to begin with. Like you don't want, like 1 doesn't correspond to 1 anymore. In this case, 1/2 course will get you 1, because you get 2 times a half is 1, square root of 1 is 1. So it might be something to remember. If you're between 0 and 1, you're a stretch. So like a half would be a stretch, and greater than 1 is a compression. And if you're negative, it's like a horizontal reflection. It's over the y-axis. Okay. And in summary, like these parameters here, the a and the c are on the outside of the function, so they happen to the verticals, which is nice. The k and the d happen to the horizontals because they're on the inside. They happen to the inputs. Stretches and reflections are the things. Stretches, compressions, and reflections are things that change a shape. Reflections and stretches, compressions should come first. So we'll see that when we actually combine a bunch of them. And then shifts would come after, because shifts are really nice to just shift the graph. And then we use the key point instead of trying to just like figure out what numbers to sub in. We use the key points, and then we look at how those points are changing. And then you can look at some of those notes there too.